Where? I'm curious, did anybody check your answers? So here's, let me check. Here's the homework. Here are the answers. Go to page 17. All right. Well, now you know. My answers are right there. Your answers don't have to be exactly like mine, but these are printed out from the thing that I just showed you. So you can, don't forget, if you want to check your answers as you're doing it, that's a good idea. Don't just copy my answers, but if you check the first one and it's way off, then you can maybe get on track and do the rest of them right instead of doing all of them wrong. So action-reaction pairs. If somebody walks to the left, the key is the person has to push the ground to the right. So that would, if this were a test and you didn't say something about pushing the ground rightward, I would take off a little bit of a point, because specifically to go left, you've got to push the ground right. And which way does the earth move when you do that? So if you push the earth to the right, you go to the left and it goes to the right. Who moves more? You or the earth? You, because the earth's so big, it doesn't move much. Squirrel climbs up a tree. Which way does the squirrel push the tree if it climbs up? Down. Just pushes the tree down. And the tree pushes the squirrel up. So anytime you climb, if you climb a ladder, the ladder is pushing you up the ladder. It is. A ball falls from the sky. This one really messes people up. The earth pulls the ball down. The ball pulls the earth up. So I'm going to drop my pencil on my paper. When I did that, the earth moved upward toward my pencil. Did it move much? No, because it's so big. So the same force that was pulling my pencil down pulled the earth up, and the earth's too big to really get affected much. Now I didn't show my work on these, so I should maybe add a little bit if anybody wants an explanation. Let me just tell you what the answers were, though. So this upward force on the left one is 80 newtons. This, the mass is 40 kilograms. The net force is negative 320 newtons, or 320 newtons downward. So does anybody want me to explain how I did any of that? Okay, so I can't really remember, but does somebody who did this know what you have to do first? Because usually there's something you have to do first. The net force. Well, you can't really do the net force because. So which one of these missing things did I have to find first, Gianni? The mass, yeah. So you can, with net force, there are two ways to do it. You can say net force equals ma, and you can use this triangle where you've got net force and you've got m and a. So if you have two of those, you can find the other three. But we have a. We don't have m. We don't have the net force. So that's not really helpful. The other way to find net force is to add up all the forces, the sum of all the individual forces. And we have this individual force, but we don't have that one. So we can't really do either of those. So the only other trick up our sleeve is this formula for weight. Weight is mass times gravity, or mass times g, which is the acceleration of gravity. And g is how many meters per second squared. Anybody blurt it out? 10, about. It's really 9.8. We're using 10 just to make the math easy. So I could turn this into a triangle too if I wanted to, but it's super easy math since this is 10. So we just say the weight, which is 400, equals the mass, that's what I'm looking for, times 10. So what do I need to multiply by 10 to get 400? What number multiplied by 10 gives me 400? 40. So that's how I know this is 40. Once I know this is 40, then I've got this mass, I've got the acceleration, I can plug them in here. 40 times negative 8 is negative 320. So that's where I get this net force. It's the mass times the acceleration. And then once I have the net force, then I can do this. I can say the net force is negative 320, which means the downward force has to be 320 more than the upward force. So this upward one is just going to be that minus 320. Or I can write it out like this. I can write the net force, negative 320, equals the sum of these two forces, and I can call this one negative 400, and I can call this one F, because I'm just doing some algebra here. So if negative 320 equals negative 400 plus F, how do I get F alone? How do I isolate it? What do I do to both sides here? Add 400. So if I add 400 to the right side, I just get F. If I add 400 to this side, then I get 80. So that's how I get that. On the one over here, it's kind of hard to read some of this stuff. This force to the left is 20. This mass, oh, I screwed up. I wrote mass as 3 newtons. What's wrong with that? Yeah, the units for mass are kilograms. This mass should be 3 kilograms, not newtons. This weight is 30 newtons. The net force is negative 12. So there were 1, 2, 3, 4 things to find there. Yeah, Gianni? Oh, I guess one more. This is 8.
How do you know, like, that the up and down forces are going to be equal? Like, how do you know that it's not trying to find that one?
Yeah, I guess you don't really. But you just, right. You can just assume if I draw a picture of something sitting on the ground, if it's sitting on the ground, they're equal. Yeah. So I didn't say that here. So it would be nice for me to say a box is sitting on the ground while it either moves left or right. It's going to be moving left or right. It's not moving up or down. So that would tell you that this upward force equals this downward force. So that's how you get this one. And by the way, this one was already given in the first place. It wasn't something you had to figure out, I don't think. So you can figure this one out first, and then once you get that, once you have the weight, you can say the weight equals the mass times g. So 30 equals the mass times 10. What does the mass have to equal? Have to equal 3. So then I know the mass is 3, and what can I do then? Then I can multiply the mass times the acceleration to get the net force. 3 times negative 4 is negative 12. And then once I have the net force, negative 12, that tells me which of these two forces is stronger. Is it going to be the one to the right or to the left if it's a negative net force? The net force is negative 12. Is that leftward or rightward? Right. No. Leftward. Which means of these two forces, the rightward force and the leftward force, which one's stronger? The left. And it tells me how much stronger. So I've got a 20 Newton force that's 12 newtons stronger than the other one. So this has to be 12 newtons less.
Maddie had a really good question.
Yes, Maddie.
I said I don't understand.
You mean I wrote it over here? I can write it here. Negative 12 newtons. Yeah, it's the negative symbol. I just had to put it somewhere. Doesn't matter where you write it. Okay, so if you had trouble with that, if you have trouble with any of these and you just want to practice some more, you can always you can either ask me for a clean copy of this, or you can get one. Why is this Spotify on? You can get one from my website. Might need to scroll down a little bit until you see something about the unit handout right here, this PDF. So you could open this up and you could print that page that we just did and try those again without looking at the answers. Even though you've already done it, it's still a good exercise. I doubt everybody has it memorized. So you could just print page 17 here and try it again.